This is Unit 7, Section 1, Notes and Examples. Alright, so now we're moving on to exponential functions. So this first section is about graphing exponential functions and some key characteristics about them. So, A is growth and decay. So we're going to classify these as exponential growth or decay and then sketch the curve. So before I do that, let's do some notes. So the first thing we need to know is what is exponential growth and what is exponential decay. So we have a basic exponential function right here. So our basic exponential function is going to be y equals some number with an exponent, where x is the exponent. Okay, that's our basic form. The more complex form would be y equals a times some number with an exponent minus h plus k. So that's the full form of an exponential function, but the y equals bx is just the basic one with nothing really extra to it. So these are what we're going to be talking about today. Now, for exponential growth and decay, so let me go back over here. So we have growth is when b is greater than 1. Okay, so b means the number with the exponent. Or if you need to, it's whatever is in parentheses if you have them, or if it's, whatever number, if it's the only one. It's just the number with the exponent is the b. Okay, and a growth graph starts at the bottom left, right above, well, I say bottom left, right above the x-axis on the left and goes straight up like that. Okay, that is positive growth. And then we have negative growth, which is a thing. So negative growth is just a mirror image of that. So I still start right below the x-axis and then I go away from it. But in both instances, notice I start right next to it and then I move away from the x-axis. That is growth. So growth is going away from 0, whether it's positive or negative, because x-axis is 0. Okay, my other one that I have is decay. So if growth is greater than 1, decay is when b is less than 1. Okay? And then we have positive and negative decay, just like growth. So we have positive decay. So decay, so on growth, I'm moving away from the x-axis because I'm moving away from 0. Decay, I'm going to be going towards the x-axis, but I go right above it. I never really touch it. I never cross it. Okay, that's positive decay. And then we have negative decay. Again, I'm start away from the x-axis on the negative side and go towards the x-axis and then kind of level out. Okay, so those are basic exponential functions. Basic growth, basic decay, and positive, negative. But it all goes off the b. So whatever the base is, that's why it's a b. The base tells you growth or decay. Alright, so let's look at these numbers and do these real quick. So if I look at this, I have my a times b to the x, and remember, I only want b, so this is the number I'm looking for. You don't need to worry about the one in the front, because the base tells you everything. So because 0.4 is less than 1, this would be decay. And then my graph, because it's a positive, I'm going to start up here and go down towards the x-axis and then level out. And that's my decay. So that's all we're doing for these questions, is labeling growth or decay and then sketching the graph. Alright, look at 2. I only have one number, so this will be easier. This number right here, 8 over 7, is greater than 1, so this would be growth. And it's positive, so I'm going away from the x-axis. I'm going above because it's positive. Okay, that's all we're doing. Number 3, Okay, I have b is my base. I don't need this a, this number in the front. 2 is greater than 1, so it is growth. And again, growing, I'm positive, so I'm going up away from the x-axis. So that's basic growth and decay. I'm either going away from x or towards x, but I never touch it. I never cross the x-axis, okay? And we'll talk about that more in a minute. But basically, these are the shapes that you will see, and it's all dependent on b, which is the base. All right, next part, Y-intercepts. Okay, there's some steps you can follow to do these. The first step is always, I don't know why that's different, change x to 0. Okay, because we're talking about Y-intercept, that's where it crosses the y-axis. Well, anywhere on the y-axis, the x value, the x point, is always 0. So I change x to 0, then I solve for y. And then my answer, once I solve for y, is always going to be 0, comma, and then whatever y is, okay? So I solve for y, but my answer is not going to be a number. It's got to be a point, 0, comma, whatever the number is. All right, so let's look at these. So notice I have my x up here. I just change that to 0. So I have y equals 3, 0.4, and then instead of x, I'm going to write 0 minus 6. Now, if you remember from last unit, anything with a 0 exponent changes to 1. So if you need to, you can write y equals 3, and then I change all of this becomes 1 minus 6. I can write it like that. That's totally fine. Or if you just, to save time, whatever you want to do, anytime you see a 0 exponent, you can just cross off the number with the 0. So look at what I have left. I have y equals 3 minus 6. Because 3 times 1, or anything times 1, is the same thing. So really the parentheses just goes away if I have a 0 exponent. Okay, now I just subtract. So y equals 3 minus 6 is negative 3. So my answer, because that's y, remember my answer is always 0, comma y, which is negative 3. Okay, so that's all we're doing. Change x to 0, solve for y, write my answer. Okay, so 0 exponent, it just goes away because it's a 1. I don't really need to write that. So now look at the next one, 5. I would do y equals 16, and then I do 8 over 7, and now I change this x to a 0 minus 1. Okay? Now I have a number, I actually have to do something. So I do 0 minus 1, I get y equals 16 times 8 over 7. 0 minus 1 is negative 1. Okay, if you remember from last chapter, or I don't know if I don't remember. Some point, I think I've talked about this. Yeah, we did last chapter. Never mind. Or did we? No? I don't know. If not, I'm going to tell you now. Anything with a negative exponent flips the number. Okay? So down here, if you need to write any number with a negative exponent, I would just have 1 over that number with the same exponent. Okay, just the same, if I had, well, let's just do some examples. If I had 3 to the negative 2, I would change that to 1 over 3 squared. If I had 1 over 5 and the whole thing was negative 3, that would flip that to 5 to the third. So if it's a 1 on top, it's just a whole number when it flips, or if it's a whole number, it's just a 1 on top when it flips. But regular fractions might be a little easier. So if I had 2 thirds and it was to the negative 2, I would flip it. It would be 3 over 2 squared. Okay, so I'm just taking the fraction, I flip the fraction, and I change the exponent to positive. So the exponent doesn't go away. It's still there. So in this case, I would still have to do 3 over 2 times 3 over 2. Or in this case, like if I flip it, I would have to do 5 to the third power. So I don't get rid of the exponent, it just flips the number. Okay? So let's go back to our question. So we have negative 1. So now, y equals 16 times, I flip 8 over 7 becomes 7 over 8. And now the negative 1 becomes positive. Now if it's a 1, you don't have to write it, because 1 doesn't really change anything. And now I can get my answer from here because I can multiply 16 times 7/8. Now, if you've been watching these all year, I always say the same thing. Anytime you multiply fractions or anything with a fraction, I always reduce first. It just makes it easier to multiply. So I can reduce 16 and 8. That becomes 2 and 1. Now I can multiply, right? Because now I have a 2 times 7 over 1, which is 7. So 2 times 7 is 14. And if you need that written out, so if I changed it, I would have y equals 2 times 7 over 1, which is 14. So same thing, right? So always reduce if you can. It just makes it easier. You don't have to. You can multiply 16 times 7 and then divide by 8, but you will still get the same answer. So why not do it the easiest way possible, which is reduce first. Alright, so remember, 14 is not my answer. I have to write 0, 14, because that is my y-intercept. Y-intercept is not just a number, it's a point. Alright, last one. Same thing, change x to 0. So I change x to 0. Now, I don't have anything else, it's just 0, so I can get rid of that. And whatever's left, I have nothing else to do, so that is my y for my point. So my answer would be 0, 1/6. So if you ever get a 0 exponent, it's definitely a lot easier. If you get a negative, remember to flip it. And then if you get something squared or whatever, just square the number and go from there, okay? Alright, well, there we go. So that's B, y-intercepts. Alright, C, transformations. Okay. So we have y equals, I don't know why that does that all the time. There we go. So y equals, I have a times b x minus h in the exponent, and then plus k. So we're looking at transformations. I will go ahead and just go over them real quick. First thing that I would look for is if I have a negative in the front. So negative in front, I would automatically reflect. Okay, that's the first thing I look for. After the negative, I would move on to a. If a is greater than 1, then I stretch. Or if I have a fraction, which you'll have a fraction in the homework. So if you have a fraction, then I always stretch by the top number. Okay, so if it's like 2/3, I would stretch by 2, because 2 is on top. And then if a is less than 1, then I would compress. And that one is always by the bottom number. Okay, so if it's 1/3, I compress by 3. If it's 2/3, I stretch by 2 because that's the top. I compress by 3 because that's the bottom. Okay? Because 2/3 is really 2 times 1/3. So I am stretching and compressing at the same time. You can say you're compressing by a single number, but to avoid confusion, I just don't want to do that, so we'll just keep it separated, and it's the same thing. Don't worry about it. So stretching and compress, I stretch by the top, I compress by the bottom. So if I had 1/3, you wouldn't say compress by 1/3, you would just say compress by 3. Alright, next thing I look at is h. So if I add h, then I shift left, because remember h is always backwards, it always flips. Well, it also flips directions. So I shift left and then however many it is, right? And then minus h, I shift right. And then the last thing is k. So if I add k, I shift up. If I subtract k, I shift down. Now, if you notice, in all of this that I wrote down, nowhere did I mention the b, so I don't use the b at all. The b does not transform this function at all. B is the base. The base creates the function, okay? So when I go through these and I'm looking for transformations, if you really need to, and it's totally fine if you do this just for transformation questions, you can go ahead and cross off the parentheses or the base. I don't need it. And I don't want you to accidentally write it down or choose that number, because that number will never be included in a transformation. So now if I look at this, I have a number in the front, that's my a, and it is greater than 1. So for this, I stretch by a factor of 3. Or if you just want to say stretch by 3, that's fine. On the test, you'll see it. I'll write it out the right way. That's fine. But just for homework, just know that you stretch by 3. Okay. So I'm stretching by a factor of 3. I don't have an h over here. Like there's nothing here, right? There's nothing. There's no k, and there's no negative. So that's the only thing that I do on that one. So that one was fairly simple. All right, number 8. Again, I don't want my base. I ignore that. That is not a. That is my b, and I don't use b. But I do have a plus 4 and a minus 3. So this one's h, this one's k. So if I add 4, that's plus h, I would shift left and then 4, because it's 4. And then minus 3 is minus k, so then I would shift down 3. And there's no a, there's no negative, so that's it. Alright, last one. Again, get rid of my b, I don't need it. Now look, I have a negative, I have a 2, I have a minus 1, and a plus 1. Now, please don't get confused. The negative 2 is not a negative a. It's not a by itself, so I wouldn't say negative 2 is less than 1. That's not true. The negative is separate from the 2 when it comes to transformations. That is the only time that you will do that. So because I have a negative, the negative by itself reflects, okay? So once the negative makes it reflect, I can't say that the negative goes with the 2. It cannot do two different things at the same time. So negative reflects, but the 2 by itself is greater than 1, so it would stretch. Then of course it would stretch by 2. Or if you want to do stretch by a factor of 2, same thing. Alright, then I have h, I have k. So if I subtract h, I shift right 1. And then plus 1, I go shift up. Well, I don't go shift. I shift up 1. And that's basic transformations. Now, it's the same as last chapter. It's the same as every chapter because transformations are always the same. So if you're, hopefully you've gotten kind of used to these, and these are getting a little easier. All right, last part is this, graphing. Okay, so I posted this chart that I made on the last one. I'll go ahead and just write it on here just like I did in class. So if you want, you can have this. If not, that's okay. So I have growth. I have decay. Okay, let's see. So I'm not sure how far down I need to go. So over here, I'm just going to copy what we have to fill in for our answers. So I have domain. I have range. I have end behavior. I'm going to skip a little bit of space because I have 2 of those, right? What else do we have? Y-Intercept and Asymptote. So Y-intercept and then asymptote. Okay, so now I can go ahead and draw my lines. So if you want to make this chart, you can. It's kind of like a cheat sheet, if you want to call it that, a reference guide, whatever. This will help you fill this out. Of course, if you're looking at the answer notes that I have posted in Canvas, I kind of go through and they're listed a little bit differently, but they kind of explain some of this. But I'm just going to make a little reference guide and kind of talk through it. So domain for both of these, this is nice, is all real numbers, no matter what. So whether I have growth, whether I have decay, it doesn't make a difference. It's always going to be all real numbers. All right. Now, range. Range is always going to be the same type of answer, not necessarily the same number. So my range is always going to be y is greater than k, whatever k is. My decay, y is greater than k. All right. Now I will say, I guess I should add this. This is for positive. Positive growth, positive decay. So if I have negative, its y is less than k on both. All right. Now I do try to focus more on the positive for both as far as the homework and then the practice, quiz, test, and everything. But I did put some negatives in there just to show you what it looks like. So just so you know, positive is greater than. If it's negative, you just flip the sign, but it's still k. All right, in behavior. So in behavior, you will always have x approaches infinity, f of x approaches blank, right? You'll always see these. So as x approaches negative infinity, f of x approaches blank. And then the same thing on this one. So I'll go ahead and write these first. And if you're wondering where I get these from, if you just look right above where we have to fill this stuff out, you'll see these just like this. And usually this is how you'll see it anyways. Like they always have the infinity, negative infinity. You have to fill in the y, the f of x. Alright, so if you need to pause it to write that down, that's fine. So, for growth, now let's just think about this logically. If I'm growing, I'm positively growing, right? Positive growth, I should be going positive forever because you're always growing. So if I'm going positive forever, that would be positive infinity. And then the negative side, the negative infinity, if you think of where do you start the graph, well, the graph, remember, starts right above the x-axis. Or, in this case, it'll be k. So this one's k, because that'll move my asymptote, which I'll talk about in a minute. So just know on growth, my positive infinity is positive infinity, my negative is k. And then for decay, if you guessed it right, you probably did, you just flip those. So the first one is k, and then negative infinity is positive infinity. So they just switch places. Alright. Now the only thing you want to add here for the negative growth, negative decay, so if I have negative, I would just change to negative infinity. So like the negative would go here. I'm not going to write that because it's positive. But just know if you have a negative growth, I would just change to negative infinity, and then same thing here. So negative decay, I would just change to negative infinity. That's the only difference for negative change. Alright, Y-intercept we've already talked about. For both of them, it would be 0, y, which I have to solve for. And that's the same for this one. And the nice thing about this also is it's true for negative and positive growth and decay. It doesn't matter which one you have, you will always find the y-intercept the exact same way. So that answer will never change. And then the asymptote, will also never change. If it'll let me write. Okay, asymptote you'll write as y equals, and then k, whatever k is. Y equals k, same thing. And then of course for negative it's no different, it's just always k. So asymptote, what do I mean by that? An asymptote is simply a line you'd never cross. So a line you never cross. And if you want to write this, because this might be important to know too, as far as exponential functions go, these will always be a horizontal line. Well, horizontal dotted line. So whenever you see a dotted line, that represents an asymptote, and that's true for practically anything in math. And for exponential functions, your asymptote is always horizontal. Alright, so we have this nice little chart that we can reference. Again, if you want to look at the other notes, I have some other things typed out that you might want to write down if it helps you. But this is basically what you have to go through and figure out. So, the first thing I would figure out on here is this graph, or this function, growth or decay? So remember, you look at b, that tells me 3/4 is less than 1, this would be decay. Alright? So if I have decay, I'm going to follow this right side of my chart, and it's positive. Okay, so I just follow the right side and do all the blue stuff. Alright, so domain, all real numbers. That one's always true, always the same. Range, y is greater than k. In this case, k is -4. So y is greater than -4. Alright, in behavior. Well, if I look at my chart that I have, because I have decay, as x approaches positive infinity, f of x approaches k, which is -4, and then the other one is positive infinity. Alright, y-intercept. I know it's going to be 0, comma something, right? I just got to solve for the y. We'll do that in a minute. And then the asymptote is always y equals k, so -4. So look at that. Without doing really any math, I've done almost every answer except for the y-intercept. Okay, so let's go do that. Alright, to get y-intercept, remember I change my x to 0. So I have y equals 3 times 3/4, and then 0 minus 1 minus 4. Alright, so I do 0 minus 1. I get 3/4 to the -1 minus 4. Remember, the negative flips the number. So I'd have y equals 3 times 4/3 to the negative, or minus 4. Okay, so I can multiply or I can reduce first. So the 3's would actually cancel out. They become 1's. So that's just 1 times 4, right? So I get 4 minus 4, y equals 0. So I got 0 for y, so when I go back over here to y-intercept, it's 0 comma y, which happens to be 0. Now, please don't think that it is always 0, 0. It is not. I promise. It will change. Okay, so now we got to graph this. Alright? Okay, so I don't need any of that. So here's how I graph this. This is the order that I always go in. Again, you can go in a different order if you'd like, that's fine. I always graph y-intercept first, asymptote second, and then just do the growth or decay. Okay? Which, if you wrote those graphs down on the first part that we did, you'll have the shapes. That's just the shape you follow. So let's start with that. So y-intercept is 0, 0. That's right here in the middle. And then my asymptote is -4. Now remember, we wrote down that it's a horizontal dotted line. So I go down to -4 right here, and I do a horizontal dotted line. And if you're thinking, well, how do I know to go down and up and not left and right? Well, if I went to don't write this down. If I went to -4 here, I couldn't write a dotted line horizontally. That would just be on the x-axis, right? You don't want to do that. And because it's y equals, it should cross the y-axis. Anyways, so it's always a horizontal line, so I just go to that number. And now I can do my growth or decay. Well, we already said that it was decay, right? So decay, and it's positive decay. So decay, I just got to start somewhere at the top up here, and I go down through, whoa, don't do that. Okay, so I go down through this point, my y-intercept, and then I kind of level off right above my asymptote. So right above the dotted line, you should kind of level out and be right above it. And again, it doesn't have to be perfect. As long as you're going down through the y-intercept and you level out above the dotted line, you have your graph. Okay? The only things I'm going to be looking for are the correct y-intercept, the correct asymptote, and then the correct direction, either going down or going up, depending on what you have. Alright, and that is the notes for 7-1. Please do the practice, please do the homework. That's the only way that you're going to get better at any of this stuff.